Here we see we're graphing and defining characteristics of the transformations of the square root parent function. The square root function being y equals, parent function being y equals radical x. We know what the graph of that looks like by plotting points. We know the domain and range are both x greater than or equal to 0 and y greater than or equal to 0. And we know that we can find our values for h and k. H is always the number that's being subtracted from the x, and k is always the number that's being added to the outside of the function, and a is the number, the coefficient of the radical. So in both of these cases, the a, here the a is 1, and over here the a is negative 1. So negative 1 times radical x plus 2. But let's go ahead and start here. We know the h value is 3, because 3 is being subtracted from x, and the k value is 2, so because 2 is being added to the outside, which means the original point of 0, 0, we go to the right 3, 1, 2, 3, and up 1, 2. A is positive, A is 1, so basically we know that that key point right there at 3, 2 is where we start the graph. Maybe it goes a little bit flatter than that, but that's the shape of the graph right there. Let's go ahead and draw the graph of this function over here. We see that h is negative 2. A here is negative 1. Over here a was 1. I meant to mark that down. But a being negative 1, negative in front would mean we're going to flip the graph of the parent function over the x-axis. That's a reflection about the x-axis, and which means we're going to reflect it about the x-axis, and then we're going to go left 2. So reflected about the x-axis looks like that. And then left 2, 1, 2, where's that? 1, 2 right there. And so we have the key point starting right there at negative 2, 0. And the graph looks like that. Let me draw this a little bit darker as well. And those go on forever in those directions. So from those two graphs, we can clearly, hopefully clearly show the defining characteristics. And what I like to do here is just draw the graph down here. It starts at 3, 2, and it goes up and over like that. That's the first one, and we'll find the domain there. So that's 3, 2. The domain would be all real numbers x, such that x is greater than or equal to 3. Now, if we wanted to find the domain using the function, we would just say that x minus 3 has to be greater than or equal to 0. We would take what's under the radical, and we would set it greater than or equal to 0, and adding 3 to both sides, we would get x is greater than or equal to 3. The range, we like to get that from the graph. We see that y, the y values are such that y is greater than or equal to 2. The function is increasing over the entire domain, so from 3 to infinity. It's never decreasing. We can see there's no horizontal and vertical asymptotes. In this case, there's no x-intercept. None. There's not even a y-intercept either. Maximum value, none. Goes up and up forever. Minimum value, though, there is a minimum value of y equals 2. 1 to 1, yes, it is 1 to 1. Slope, we're just not going to worry about that. It's a decreasing slope, but so if you want to get specific, the slope is decreasing. Initially, the slope is kind of like a 1, and then as you move to the right, it's decreasing. There is no vertex on here, and there is no axis of symmetry. So that takes care of the first one, and defining characteristics. Let me go ahead and I'll do this one as well here, so we can do this all in one video. Again, the initial point on this graph is at negative 2, 0. So the domain would be all real numbers x, such that x is greater than or equal to negative 2. And again, we can find that by taking what's under the radical, which is x plus 2, and setting it greater than or equal to 0, and subtracting 2 from both sides, we get that. And the range would be all real numbers y, such that y is less than or equal to 0. If you wanted to do that, write that in interval notation, you would write negative infinity all the way to 0, including 0. So in this one, we would have from negative 2 to infinity, the domain negative 2 to infinity, using interval notation. Increasing, never. decreasing for all real numbers that are in the domain. So from -2 all the way to infinity, whether you put a bracket or parentheses around that, doesn't matter. No asymptotes for this function. The x-intercept, we can clearly see that it hits the x-axis at -2, 0. The y-intercept, on the other hand, that when we set this equal to 0, so let me do the y-intercept down here. Y-intercept would be when negative radical x plus 2 is equal to 0. Dividing both sides by -1, we would get radical x plus 2 equals 0. Now we're going to have to square both sides. When we square both sides, we get x plus 2 equals 0. And when you subtract 2 from both sides, we get x equals -2. Why did I do that? Oh, that's the sorry, that's the x-intercept. I'm not very smart right now. Let's do the y-intercept, was when we let x equals 0. My bad on that one. Y equals negative radical 2. So when you let x equal 0, you get 0 plus 2, so it's negative radical 2. I was wondering why that was looking like that. So the y-intercept would be 0, negative radical 2. Trying to hurry right now. Maximum value would be 0, the y-coordinate of the end of the range. So the end of the range, the maximum value is 0. Minimum value, there is none. 1 to 1, yes, because for both of these, horizontal line crosses only at 1 point maximum. Slope, and this one would be increasing, but I'm okay with you saying NA for that. Vertex, none, and there is no axis of symmetry. Sorry for the mistake there, but that's it.